Can't even go there.
Sounds good, yeah, I don't know. Okay.
Well, our wise guy, Matt Sellen, is proving once again how very brave he is.
But first, he's going to teach us about energy conversation. Matt, what does a bowling ball have to do with energy conversation or conservation?
Good morning, Matt.
We'll get to that in a second here. But first of all, we learned something very important from that first segment there, which is that experiments don't always work. And you're always supposed to learn even more when an experiment doesn't work. And what I learned from that one was that Murphy's Law actually is pretty active in our lives. So anyways, if something's going to go wrong, it tends to go wrong pretty badly. So anyways, that should have blown up, but it didn't. Nevertheless, what we've been doing this whole time, really, in the last month or so, is we've been burning and blowing things up. And those are great examples of turning one kind of energy into another kind of energy. And it turns out that if you take into account all the different sorts of energy around us, the total sum of those things don't change. They just change from one to another. And the kinds of energy that we experience with are kind of three categories. There's heat, there is energy of motion, which we sometimes call kinetic energy, and then there's energy which is ready to be used, which we sometimes call potential energy. And so in the case where you blow up a balloon, or you burn some gasoline or something, you are getting the energy out of that gasoline, which you can think of as potential energy, and you're making heat. Quite often, or the most useful kind of energy is the energy of motion, which is kinetic energy. And so let me do a couple of experiments to illustrate that you can turn potential energy into kinetic energy. Okay? Gravity provides potential energy. If I lift up this bowling ball to a high spot and then I release it and it falls back down to where it was, it's moving pretty fast when it gets back down here. Up here it has potential energy, down here it has kinetic energy because it's moving. Okay? If you've ever played with Hot Wheels, you've seen this in action. Here's a little Dodge Charger. I let this thing go. It starts at rest up here, and then it falls down, and it's moving pretty fast at the bottom. Up here it has potential energy, down here it has kinetic energy. This rubber band, when I stretch it, has potential energy. When I let it go, oops, sorry, Scott. It has kinetic energy. Okay, and this brings us to the bowling ball. A bowling ball is what I have here, basically hanging from the end of a wire. When I lift this thing up by bringing it to one side, it's not moving. It has no kinetic energy at all. It has potential. When I let it go, it starts to move. It goes up to the other side and stops. So at the end points of its motion, it's up high. It has potential kind of energy. At the bottom here, it's moving fast. It has kinetic energy. If you add it together, the sum of the potential plus the kinetic, you would always have the same exact number. And that's very important for the next demonstration that I'm going to do, because I'm going to risk my life here by standing up. Actually, I'm not risking my life because I know it's going to work, and you'd better get out of the way or this is going to hit you. So what I'm going to do is I'm going to put my head against this cement wall. I'm going to bring this bowling ball right up to my chin, and I'm going to release it. And now it's going to swing back, and it might be kind of scary, but I know it's not going to hit me. The reason is that energy is conserved. Okay? You don't ever get more energy at the end than what you began with at the beginning, so I know it can't swing higher. If it ended up swinging higher, which is what it would have to do to hit me in the chops, it would mean that it would have more energy the second time around. And I know that doesn't happen because I have complete confidence in energy conservation. So I can do that demonstration. Okay, now this all kind of... Sorry. So anyways, next week we're going to talk about gravity, and gravity has to do with everything, or a lot of things that I just did here. And so the question I want to ask for next week is, if I have a wooden block and a lead block, and I release them at the same time, one is very light, one is much, much heavier, which one hits the ground first? That's the question I want the viewers to answer.
Okay. I would have to ponder that one, but hopefully I'm sure people will know the answer, and I'm really impressed with that bowling ball. I even heard someone go, ooh. I assume that was Scott's. Well, if you think you might know the answer to that one, you want people to write you at wiseguy@wiuc.edu. That is your email address, and get the answer to the question. You will demonstrate that for us next week then.
I will.
Okay, thank you so much, Matt Sellen. We appreciate your efforts this morning.
I tried.
You did a real good job. We're impressed. Now, the way the morning's gone, I don't know that I would have done the bowling ball thing. But...
Right.
Okay, thanks, Matt. Time now for a look at today's weather.